This is our last lesson on factoring. So far, we have looked at the GCF, which we can apply to any type of factoring problem, the difference of two squares. We've had all kinds of trinomials. Our last lesson dealt with grouping, if you had four or more terms. And now we're going to look at the sum and difference of cubes. So just like on squares, we need to be familiar with some common cubes. So why don't you take a minute and fill out this table. These are our common cubes because you can see the numbers get really big pretty fast, so we want to stick with kind of the small ones. Now I want you to pay attention to this one and this one. 1 is also on our square table, right? 1 times 1 is 1. And 64 is also 8 squared. It is also a perfect cube to 4 cubes. So you need to look at the other part of the problem to tell you, are you going to work it like squares or are you going to work it like cubes? And it's pretty obvious. Usually you have like x cubed instead of x squared. Let's first review our distributive property before we look at those cubes. Remember, our distributive property just says we take everything in the first parenthesis and multiply it times everything in the second parenthesis. So I'd have x cubed minus x squared plus x. Then I would take the 1 and distribute that as well. And then I would collect like terms. Well, I have x cubed. Then I have a negative x squared and a positive x squared. That's 0. I have a plus x and a minus x. That's also 0. And then I have a plus 1. Look at what I have left. This would be the sum, because there's a plus sign, of 2 cubes, x cubed plus 1. Look at where it came from. Remember, factoring is looking at patterns and going backwards of multiplying. What about this one? If I use our distributive property and multiply all of those times x, then multiply everything by negative 2, and collect like terms, I would have a positive 2x squared and a minus 2x squared, a positive 4x and a negative 4x, and a minus 8. This would be what's called the difference of two cubes. Look at where it came from. So again, when we are factoring, we're going to take these answers and go back to here. So that's why it's important to know how to multiply, because factoring is dividing, which is the inverse operation of multiplying. So we have to look at those patterns and say, where did that sum of two cubes come from? What did we have? We had a binomial times a trinomial. A binomial times a trinomial. So our job today is to figure out what that binomial and trinomial is. So again, we're going to be looking at patterns. So how do we factor cubes? A lot of books teach it as formulas, and you can go back and do that, but I'm going to teach it to you in words and patterns. So first of all, you need to recognize that you do have cubes, and it can have a plus or a minus sign, it doesn't matter. Okay, we're going to start with a binomial, 2 terms, just like the problem. So whatever that sign is in the problem, you're going to bring it down, and then you're going to ask yourself, what cubed is x cubed? X. What cubed is 8? What times what is 8? That's 2. So that's part of your answer. That's our binomial. Then we're always going to have a trinomial. How are we going to get what's in that trinomial? Well, it's going to come from the first parenthesis. You're going to square this, so that's going to be x squared. And you're going to square that, so that's going to be plus 4, because 2 times 2 is 4. And then the middle term, I know this is kind of messy, you're going to multiply those together, and then take the opposite sign. So 2 times x is 2x. It was positive, so we're going to make it negative. So the answer to that problem is x plus 2 times x squared minus 2x plus 4. A binomial times a trinomial that cannot be factored further. Number 2, we have the difference of two cubes. So we're going to start out with a binomial, x, then that sign. Then we need 5 times 5 times 5 is 125. Then we're going to have our trinomial. So we're going to square the first thing, square the second thing, and remember, negative 5 times negative 5 is positive 25. So that sign is always going to be positive because we square this term. Now, the middle term, we're going to multiply those together and take the opposite sign, and that goes in the middle. So negative 5 times x is negative 5x, but then we would take the opposite sign. That's the answer. So let's just pause for a minute, look at the signs. If our problem started with minus, so our problem starts with minus and then a plus, and then this is always positive. If our problem starts with plus, we start it with the plus, then the opposite, and this is always positive. Let's keep going. Number 3, we have the sum of two cubes. It looks backwards. Let's just keep it like it is. We need a plus sign. Then 1 times 1 times 1 is 1. And then what makes 27 is 3, and we have to have the y. Then we have our trinomial. So we want to square that, put it in front, square that. Now that's 3y times 3y, which is 9y squared, and it's always positive. Then we multiply those together and take the opposite sign. That's it. Number 4, still cubes, just a little bit bigger looking. So we need not just 2, but we need 2x, keep the same sign, then 5y, then we need our trinomial. So we have to square 2x. Don't write just down 2x squared, that's wrong. It's 2x times 2x, which is 4x squared. Then we need to square our 5y. 5y times 5y is 25y squared, and it's always plus because you're squaring something. Then we multiply that together. So that's negative 10xy. I just like to put the letters in alphabetical order and take the opposite sign. So I like to look at this as SOS. Square, opposite, square. Might help you to remember that process. Number 5 and 6, a little bit more complicated. If you look at number 5, those are not on our cube table at all. So would it just stop and say prime? No. We always have to remember, is there a GCF? Well, let's see. Is 648 divisible by 3? I think it is. So if I take out a 3, that would leave me x cubed. 3 goes into 6 2 times, and then 3 goes into 4 1. I think that's 216. Is 216 on our list of cubes? Yes, it is. Okay, so you want to keep your 3, keep your short parenthesis. So what cubed is 216? 6. Then we fill out our trinomial. Square that, make it positive, multiply those together, take the opposite sign. Square, opposite, square. Don't forget your GCF. Number 6, x to the 4th, not a cube. It's got to have a GCF. 81 and 3 are both divisible by 3. They both have an x, they both have a y. So if I divide each of those by 3xy, what does that leave me? Well, 3 goes into 81 27 times. The x's would reduce, the y's divide out, and then that would leave me y cubed. Now I have the difference of two cubes, bring down my GCF, keep my same sign. That's right, 3x, then a y. I square that. Remember, 3x times 3x is 9x squared. I square that. That's plus y squared. Multiply it together. Just put the letters in alphabetical order. And change the sign. Cubes are easy as long as you just have that pattern. That's square, opposite square, check your signs. And when factoring the sum or difference of two cubes, you will always have a binomial times a trinomial. You may have more like a GCF, but you're always going to have a binomial times a trinomial.